Okay, in this video we're going to look at virtual form finding using Rhino, Grasshopper, and a plugin for Grasshopper called Karamba. And what you see in front of you is what we're going to end up with at the end of this video. So this mesh that I've selected was baked from Grasshopper and created using Karamba. And this other mesh is a flattened version of it that I used to make a paper model. So we're also going to look at how to flatten a surface with double curvature for making some prototyping like you see in these two photos. Okay, so let's get started. In Rhino, we're going to open up a new file, and that file is going to be large objects, feet. And this way our number sliders in Grasshopper, when we set it to 12, it represents 12 feet. Or when we set it to 4, it represents 4 feet versus inches. So we'll work in large objects, feet. And we're going to work here in a perspective view. And let's go ahead and make this grid easier on our eyes. If we type in DOC, enter, we'll bring up document properties. And from the vertical toolbar on the left, we'll go to grid, and we're gonna work relatively small. So this example was created for creating some form-found ice structures, full scale, built outdoors in the winter. So we were working with a footprint of about 6 foot by 6 foot by 6 foot. So our grid line count for this can be 10, and our minor grid lines can be every 1 feet, and major grid lines every 10 grid lines. Okay, and we'll work in this upper right quadrant here. Okay, let's go ahead and load Grasshopper. And we'll keep everything parametric. We'll keep everything inside a Grasshopper. So we got to start out by making a rectangular plane or a rectangular surface. And in this case, it's going to be a square. It's going to be 6 foot by 6 foot. So we're going to construct two XYZ points. So I'm just going to double click and type XYZ, and we'll see construct point. And you see this construct point capsule puts a point at 0, 0, 0, and I'm going to need a second one. So in Grasshopper, if I begin to drag downward and introduce my Alt key, press my Alt key, it drags and makes a copy of it. I can scoot these over, and my next point, again, I'm working with a 6 foot by 6 foot square, so my next point, my second construct point, needs a number slider set to 6 for both the X and the Y. So I'm just going to double click, type in 6, enter, and I can plug that into the X and the Y. And if I zoom out a little bit or scoot this over, you see the second point located at 6 feet away in the X and the Y direction from the origin. Now I can make a boundary surface, and I'm going to do that first by creating a rectangle through these 2 points. So I'm going to double click and type in rectangle, and one of the options is a rectangle 2 point. So with that, I'm going to plug in each of these construct points, one into A and one into B, and that creates a rectangle passing through those 2 points. And the last thing I need to create this starting surface is a boundary surface. So I'm just going to double click and start to type in boundary surfaces, and I can plug in this rectangle. So this is my starting surface. So I'm just going to organize this definition a little bit by bringing down a scribble. Okay, so this is the starting surface. I should mention that in Karamba we're going to be working with meshes, but I'm going to create a mesh from this surface. So I'm just going to select all of this and group it together and change its color. Okay, so that's our starting surface. The next thing that we need is the mesh surface. So I'm going to go ahead and bring out a capsule called mesh surface. And I can plug my surface into it. And what I want to do with this mesh surface is I want to control the resolution of the mesh, because this mesh is going to get deformed and have double curvature, so it needs to have multiple U and V ISO curves, and that can be done here through this U and V count. So this is increasing the resolution of the surface. So I'm just going to Control G this and right click and put that in the name of it, so I know that for later on, so that this controls resolution. Okay, and what the resolution that I'm going to use right now is 20 by 20. So I'm just going to create a number slider set to 20, and I'm going to plug that into both the U and the V. And a little difficult to see on the screen, but if I click on this half white, half green button, it's only going to show what I'm selecting. So this is my mesh surface, and we'll see that resolution a little bit better when we plug it into our shell capsule. So that's going to be the next capsule that we make. We're actually going to start using Karamba now, and we're going to tell Grasshopper and Rhino now to think of this mesh as a shell. So I'm going to bring out the mesh to shell capsule, and you see these Karamba capsules are labeled Karamba. So I can plug my mesh into this, and when I select that there, you see the resolution of this mesh surface, and I can select the mesh surface as well. I'll go ahead and unclick the white and green button to turn everything back on. Okay, so this mesh to shell capsule starts to become important. So we're going to go ahead and just label this with a name that's going to make this more clear later on in the definition of how and where we're going to use this. So I'm going to bring down another scribble, and I'm just going to label this structure. Okay, so we're going to be plugging in a lot of different capsules, and a lot of places that people get confused is this point. Somehow a lot of people plug another capsule into these points. So I'm just going to go ahead and use the sketch object here to X that input out so that it doesn't get used later on. And I'll go ahead and change the color of that. Okay, the next capsule that we're going to look at is a capsule where we're going to be assembling what Karamba needs to analyze the structure or analyze this mesh shell. So I'm going to double click and start to type in assemble, and there's an assemble model capsule for Karamba. And I'm going to look at these inputs and see what I already have and see what I'm going to need. So the inputs on the left, the first one is point, and that's going to come from my structure capsule. And the second one is element, that's also going to come from my structure capsule. The next two are support and load, and we're going to start to make those. For this intro tutorial, we're going to leave out cross-section material, beam set, and L distance, but we need support and load. And in this form finding exercise, the supports are really the anchor points. And if I go over to this other definition that I have and I look at this shell, you see that it is pinned down in 4 corners. So you can think of that as supported in the 4 corners, which it is supported there. And it's also pinned down or anchored in terms of looking at this as a form finding exercise. So the next thing we need to do is make those 1, 2, 3, 4 supports or anchors. So let's go ahead and start that process. So I'm going to bring down a scribble and I'm going to call this anchors / supports. And the first thing I need to have is a way to place those on this surface, place the location of those. So I'm going to use an MD slider, and that's going to determine the location based on the square that we have in the MD slider. That's going to translate over to this surface. So I'm going to go ahead and bring out a evaluate capsule, or an evaluate surface capsule, and I'm going to go ahead and plug that in, and that needs to be plugged into the point, not the surface. The surface needs the boundary surface that we created at the beginning of the tutorial, so I'm going to go and grab that boundary surface and plug that in. Okay, so now as I move this MD slider, you're seeing a new point show up over here in Rhino. And if I go to the upper right at 1, 1, I want that to show up at 1, 1 in the upper right hand corner of this surface. But where it's showing up now is at 1 foot in the X and 1 foot in the Y. So it's using the world XYZ coordinates of 1 foot by 1 foot. So what I'm going to do is I'm going to right click on this evaluate surface input, and I'm going to reparameterize that so that it looks at the surface now not in distance but in domain from 0 to 1 and also from 0 to 1 in this direction. So now as I move this MD slider around, it corresponds to that surface. And we're going to need 4 of these. So we're going to go ahead and just start with this one in the lower left. We need a few more things before we start to copy and paste this. So I actually now need my Karamba support capsule. So I'm going to double click and start to type in support. And there's 2 of them. We're going to use the bottom one, not the one with the hexagon. So I'll choose support Karamba. And I'm going to plug in point to position index. So the values that are coming out of point tell Karamba where the position is of that support. And what's really important here to get this mesh form found and moving in 2 directions, I need all these conditions turned on. So I'm going to go ahead and turn those on. That'll make the mesh flexible. Okay, so I have what I need for this one support, but I'm going to go ahead now and going to select all these and start to drag them down using the Alt key, and I'll position now this one in the lower right, so you see that happening in Rhino, and I'll go ahead and make a couple more of these. This one will be in the upper right. And this one will be in the upper left. Okay. So those are my anchors and supports, and I can group all of these together and change the color. Okay, so I have those. Now let's take a look back at the assemble model. So now I can plug each one of those supports into the support location. So I'll do that using my shift key. Okay, so we have all of those. The next thing that we need is we need a load to raise this mesh up and make it form found. So I'm gonna go ahead and move this assemble over and start to create the load. And I'm going to use 2 point loads. So I'm going to go ahead and make a scribble, and I'm going to name these point loads. Okay, so in Karamba there is a capsule for point load. Okay, so there's point load Karamba, and it's looking for a vector, so the direction of the load, and it's looking for a position of that load. So the vector, we're going to use a positive z so that this shell is created in the positive z direction. So I'm going to double click and type in z, and I'm going to choose unit z. So that's going to be my direction. This also is an input for the load, and my Karamba here is set to feet inches. It's the load is set to kips versus being set in metric, so it's using imperial units, so we're using kips for the load. I'm gonna make a number slider that is set to 2.000. So with this load I want a lot of decimal places, so I'm going to have 4 decimal places for the load, and I'm going to go ahead and plug that in. So I've set up my load direction, which is positive z, and my load amount, which is 2 kips. Now I need to set up the position of that load. And the position of that load needs to be from the structure. So I'm going to make a little scribble here. Not a scribble, but a sketch rather. So I'm going to just make a little loop here. And now I'll bring down a scribble. And this needs to be from structure. From structure, not the original surface, and we'll see that in a little bit here. So in a similar fashion to the way that we made the supports, and we located those supports and anchors, we can locate the point loads. So we can do that with an MD slider. We can evaluate the surface. So this is actually the point on the surface. So I'll go back and get my boundary surface and plug that in. Okay, I need to reparameterize that surface. So here you see that point load. Okay, so I can't just plug the point in from the evaluate surface to this Karamba capsule. It'll give me an error, and just to demonstrate that, I'm going to plug that in. I'll plug in, I'll plug in this point load to assemble model, and it's giving me an error because it needs the points from the structure, from the Karamba capsule mesh to shell, not the surface. It doesn't know how to, it can't find it. If I click on this little balloon, it basically can't find the point because it's not from the Karamba structure. Okay, so that needs to be from the Karamba structure. So I'm gonna unplug that. Okay, so what I need now is I can find the closest point on the Karamba structure. I can actually use a closest point capsule for that. So I'll scoot these over a little bit and add in my closest point. Careful, there's a closest points. We want closest point. And I can plug point into point. And the closest point should be the closest point from the structure. So I can add another little sketch here. This cloud should also be from structure. So that's why early on we labeled that capsule structure, and that has the points coming out of it. So I'll go ahead and plug that into my closest point. And actually, that'll actually be confusing down the road, but it made sense while we were talking about it. So plug this in, and now there is no error. It found that location of that point. So we have a point load now. We're going to add some more things to this, but right now we're just looking at this boring flat surface mesh here. So let's go ahead and get that surface to start being form found. So we need some other capsules here besides assemble model Karamba. So let's start going with that. What we need now is we need a model view. Okay. So you see coming out of assemble model, we've assembled it on the left. Coming out on the right is model. So we can plug that in. It has some settings that we'll begin to look at. You'll see now it's starting to visualize or show us. We can now view the supports in the four corners. The next thing we need is a shell view. So I'll plug in model to model. Okay, so now we're starting to see some things happen here. We want to go ahead and start to get this mesh to deform or move around a little bit. So the surface is lighting up, but nothing's happening. We're not seeing any deformation. That's because it looks like I'm missing one capsule here. I'm missing the analyze capsule. So that needs to be placed before the model view. So I'm going to go ahead and plug that in. And this will now be the model with displacements or deformation. So I'm going to plug that in, and now we start to see something happening there. Let's go ahead and organize this a little bit. Okay, so as I increase or decrease this point load now, it's going to affect the deformation on the shell structure. So I'm going to go ahead and add another point load. Also, as I move this MD slider around, it's changing the location of that point load. Okay, I'm going to bring down the amount of load on that. So I can add a second point load by copying and pasting this. But before I do that, I want to visualize the height of this point load where it reaches the shell, or the location of this point load that could be used later on for fabrication. In this case, this tutorial is being done to make a full-scale ice structure, and we want to find the location of that point load. So I can do that with a line SDL, and the start of that line can be my point from my point load, and the direction is a default of Z, and the length of that, for right now, I can just set that, say, to 3 feet. Okay, so Now I have some real scale to work with, so that if I want that to be deforming to about 3 feet roughly, I can increase or decrease my load, and I have this visual line SDL to aid in that process. So now that I have the line SDL, I can go ahead and copy and paste this stuff, and it'll create my second point load. So I'm going to grab all these capsules for the first point load and start to drag it down and use my Alt key, and I'm going to position this one toward the front here. And it's not plugged in, so it's not affecting the structure yet. So I'm going to go ahead and plug that in as another load. I'm going to use my Shift key, and you see that's now affecting the structure. And I'll go ahead and group all these point load capsules together. Change the color. Okay, so now just a couple things about the visualization of this, taking a look at the deformation. We can do a deformation map onto the structure. But before I do that, I'm going to increase this line SDL. So this one, maybe I want this to be around 5 or 6 feet. So I'm going to set that at 5, and I'm going to decrease that load a little bit. And it's going to affect the back one as well. Okay, so there I have something to scale where the front of this shell is 5 feet tall and the back is about 3 foot tall, and the perimeter is 6 foot by 6 foot. So I have something real scale to work with. Now let's go ahead and look at a couple settings. So under shell view, under render settings, I'm going to go ahead and change this from cross section. I'm going to change it to displacement. Okay, so now I'm getting a displacement color map, and I want to change the display scale and the render settings. So I'll start with the render settings, and I'm going to bring down my upper result threshold. I'm going to start to bring that toward the center, and the same thing with my lower result. So that's changing the scale of my deformation or my displacement map. I can also have additional control over the deformation here under display scales. So you'll see as I increase this, it starts to deform more, and when I decrease it, it deforms less. So just another place to control the deformation. I'm going to leave that around the default of 50. Okay, so just again, kind of play around with this. It's always fun to do this. Just kind of move the position. So this is all parametric. We're getting this model to respond to the position of the load. Alright, so now the next thing is to talk about how to flatten this surface that has double curvature. So we're going to actually be doing that in Rhino. So let me I just want to tweak and lower the back end down a little bit. Okay, that'll be fine. So what I need to do is I need to bake the shell view. So I'm going to go ahead and click on that, and I'm going to right click over the vertical shell view capsule. One thing that I didn't know at the beginning of this tutorial is that I'm viewing full names. So under display, I have draw full names turned on, so that allows these capsules to be expanded and see the full names versus the abbreviations. So I'm going to go ahead and bake that. And working with students, I've seen that they run into a problem sometimes when they bake on the default layer. So I'm going to go ahead and bake this on layer 1. And you see in Rhino it bakes the mesh, the form file mesh, and it also bakes the mesh that we started with. So there's two objects there. And I'm going to go ahead and close Grasshopper just to see what we have in Rhino. So there you go. We have the form found shell, and we have the flattened mesh that we started with. So to see the deformation mapping, I'm going to change the perspective view. I'm going to go ahead and change it to shaded and deselect it. So now we see that. And what we're going to do is we're going to unroll or flatten this surface with double curvature, and we're going to do that through the squish command. So I'll type in squish, I'll select the mesh. Nothing happens until I hit enter, and there's the flattened unrolled surface. Now when I made the paper model, I noticed, and it was actually obvious before I did it, that there's some errors in the squishing. And these sides make sense. This left side, the back side, the right side, that this should be an arch. This one, it had a little difficulty with what was happening there. So that's just something you need to be aware of, and it was something I ended up cutting out from the final photos. So that's it for the intro to virtual form finding using Rhino, Grasshopper, and Karamba.